Today's video I am going to discuss an important fundamental concept in organic chemistry, that is Markovnikov's rule and the Saytzeff rule. Now I am going to explain Markovnikov's rule. The Markovnikov's rule, we need an unsymmetrical alkene. Unsymmetrical alkene means, like suppose in the left hand side carbon you have 2 methyl and the right hand side you have 1 methyl and 1 hydrogen. So this is called unsymmetrical alkene. Now when you are adding hydrochloric acid in the unsymmetrical alkene, we have to check where the electrophile H plus add and where the nucleophile Cl minus attack. So first we have to understand the mechanism. One thing we remember, molecule does not know the Markovnikov's rule. Molecule know the stability. So first we have to check that how the mechanism is happening. Now this pi bond attack to H plus, because this is the mechanism is electrophilic addition mechanism. Electrophilic addition mechanism. So pi electrons attack to electrophile H plus, and then where this electrophile will attack. Now electrophile will attack in such a way so that we can get a stable carbocation. So now electrophile attack the right hand side carbon. So left hand side carbon is now positively charged, so it's a carbocation, and this carbocation is 3-degree carbocation, it's a stable carbocation. Now let's assume if the hydrogen H plus attacks to left hand side carbon, then which type of carbocation we are getting. So here we can see this is the carbocation is forming, and this carbocation is 2-degree carbocation. We know that 3-degree carbocation is more stable than 2-degree, that's why the reaction will proceed via 3-degree carbocation. Next step, Cl minus a nucleophile attack to carbocation and we get the desired product. So this is our final product, which is alkyl halide. So this will be the major product, and from the 2-degree carbocation we will be getting the minor product. So product is CH3 hydrogen, so this will be the minor product. Now this rule is called Markovnikov's rule. So according to Markovnikov's rule, the nucleophile attack to the more substituted carbon. Now in the alkene, this carbon is more substituted because it has attached with 2-methyl group, and more substituted carbon means when the carbocation form, that will be the more stable carbocation. So that's why nucleophile attack to the more substituted carbon, or we can say the nucleophile attacks to the more stable carbocation. So this all about Markovnikov's rule. So when we prepare alcohol or alkyl halide from alkene by using of halogen acid like hydrochloric acid, HBr or HI, or we can use water to make the alcohol, it follows electrophilic addition mechanism. And when it follows electrophilic addition mechanism, the mechanism follows the Markovnikov's rule. So Markovnikov rule is connected with electrophilic addition, and this electrophilic addition is connected with synthesis of alkyl halide or alcohol from alkene. Next I am going to explain Saytzeff rule. In this regard, we have to take an alkyl halide or alcohol. So now I am taking one alkyl halide. So this is alkyl halide, Now when this alkyl halide is treated with a strong base like sodium methoxide, let's see what is happening. First, this carbon chlorine bond breaks, we get a carbocation. So here we will be getting a carbocation which is a secondary carbocation. Now it's a secondary carbocation, so this is beta carbon, this is also beta carbon. This beta carbon has beta hydrogen, it also has beta hydrogen. Now in presence of base, deprotonation takes place. So now this OCH3 minus attack to H plus and we get an alkene. So this is the alkene we are getting. Now let's assume that base attacks this alpha hydrogen, means right hand side alpha hydrogen, then which product we are getting? So when this base attacks this hydrogen, deprotonation takes place, we will be getting a different alkene. This carbon has 2 methyl, 1 hydrogen, then carbon, then double bond, CH2. So here we are getting another alkene, B. This is alkene A. Now which will be the major product? In the alkene A, this is alkene double bond. It has 3 alpha carbons, 12 alpha hydrogens, so 12 hyperconjugation structure. Now in the second one, this is the alkene, so this is alpha carbons, these two are beta carbons, so it has only 1 alpha hydrogen, so 1 hyperconjugation structure. So more hyperconjugation structure means more stable, so that's why alkene A is more stable than alkene B, so alkene A will be the major product. And that's all about the Saytzeff rule. Saytzeff rule is telling due to elimination reaction, more substituted alkene will be the major product. This is the more substituted alkene because here we are getting more number of hyperconjugation structure. Saytzeff rule is connected with elimination mechanism. Elimination mechanism takes place when alkyl halide or alcohol is treated with a base. Then we get a alkene, and more substituted alkene formation is the Saytzeff rule. That's why Saytzeff rule is connected with elimination, and elimination reaction means we are going to synthesize alkene molecule from alkyl halide or alcohols. Let's summarize Markovnikov's and Saytzeff rule. When alkene is treated with HCl, HBr, HI or water, the nucleophile attack to the carbon which is more substituted carbon. So this is called Markovnikov's rule. From the alkyl halide or alcohol in presence of sodium methoxide or any other strong base, it undergoes elimination and we get alkene. This time it follows Saytzeff rule. So that means Markovnikov's rule follows in electrophilic addition mechanism and Saytzeff rule follows in the elimination mechanism.